Hello, I'm still your faithful Bukola Joseph. We're going to be solving a problem today on relative density. Okay, the question is already on the board, so let's read through and then tackle the problem together. Okay, now I read: the mass of a stone is 15 gram when completely immersed in water, and 10 gram when completely immersed in liquid of relative density 2.0. What is the mass of the stone in air? That's the question. So, what is the mass of stone in air? So, what are we looking for? Is it W1? Is it W2? Is it W3? Okay, if you have followed the last video before this, you should be able by now to identify what W1 stands for, what W2 stands for, what W3 stands for. But I'm still going to explain again. Now, W1 is weight of the stone in air. W2 is the weight of the stone in water, while W3 is the weight of the stone in liquid. Okay, like I said before, the liquid can be anything. It can be kerosene, it can be petrol, it can be any other thing apart from water. Is that okay? So now let's do this together. Let's solve this problem together. So if you have followed me, you've been following me bomber to bomber, I know you don't have a blockhead. I know you are intelligent. Yeah. So I know if you had followed me, you should by now be able to establish the formula for relative density, especially if it has to do with two liquids. Okay, so it means the formula is going to be the upthrust in the liquid all over the upthrust in water. Of course, you must relate, it has to be to water. The ratio is the liquid to water. Okay, so the water will always be at the denominator, while the other liquid will be at the numerator. Let's solve this problem together. Let's do less of talking and do more of solving. Okay, let's do this. Yeah. So from the question, we have the mass of a stone is 15 gram when completely immersed in water. So the 15 gram in water, so I told you that W1 is for when the body is in air. W2, are you see what I'm doing? Is for when the body is in water. While W3 is for when the body is in the other liquid. Okay. So I was trying to get another marker, but I think you can see what I'm doing. So we have W1. The mass of a stone is 15 gram when completely immersed in water. Water. What does water stand for? W2. Is it W2? Is it W2? W3? W1? W2. Water is for W2. So we have W2 15 grams. Okay, let's read the question. When completely immersed in water, and 10 gram when completely immersed in liquid. In liquid, is it W1? Is it W3? W3. So we have 10 grams for W3. In liquid of relative density. So we are given the RD, relative density, is equal to 2.0. What is the mass of the stone in air? What is the mass of the stone in air? In air, this is what we are looking for. We are looking for W1. I hope you are seeing me. I hope you are seeing what I'm doing. I'm not talking to myself. I hope you are seeing what I'm doing. So we have this information already. Okay, now what is the formula? The next thing you need to do after bringing out your parameters from the question, you write your formula. It is important you write the formula. So we have our RD is equal to what? Apparent loss in liquid all over apparent loss in water. Sorry, please. Let me see if I can find the other marker. I think this marker is. So we have RD is equal to. I don't know if you are seeing this red marker. Are you seeing it? Let me just manage my black marker. I don't think you are seeing. Let me manage the black marker. So we have RD is equal to. I hope you know that the apparent loss in liquid is the same thing as upthrust in liquid. All over. Apparent loss in water is the same thing as what? Upthrust in water. No, no, no. I know what you are thinking. Must I write the two formulas? No. Any of this formula you write is okay. Is fine. You don't have to write the two formulas. I mean, it means the same thing. Okay? Upthrust in liquid is simply apparent loss in liquid. Is that okay? So now let's solve this problem together. Permit me to wipe these other parts since we've already picked everything from the question. So let's wipe. So now what will be our upthrust? So we have RD. This marker is dead. We have RD is equal to what? Upthrust in liquid all over upthrust in water. So we have RD. So for upthrust in liquid, it's going to be W1. Look at it. Look at it. Look at it, please. It's going to be what? For liquid, it's going to be what? W1 minus W3. W1 minus W3. Then upthrust in water will be what? W1 minus W2. Are you seeing it? So if you are finding for liquid, it's going to be these two. W1 minus W3. Then if we are finding for water, it's going to be what? These two. W1 minus W2. Can you see this? I hope you saw what I did. I hope you saw what I did. You're not seeing this red marker. Okay, let me use this. I said for upthrust in liquid, we have, it's going to be W1 minus W3. Okay? And then for upthrust in water, it's going to be what? W1 minus W2. Okay? So now, let's do this. Let's do this. Let's do this together. Okay, so we have RD is equal to, in liquid we have what? W1 minus W3. Then in water we have what? W1 minus W2. So you can see by now you know that this W1 stands for weight in air, W3 stands for weight in the liquid, W1 weight in air, right? And then W2 is what? Weight in water. So let's substitute. So we have W1 is what we're looking for. We have RD. RD is 2.0. W1 is what we are looking for, which is unknown. Then W3 is what? 10 all over. W1 unknown. W2 is what? See it. The parameters are there for you. Can you see it? W1 not given. W2 is 15. W3 is 10. RD is 2.0. So we have W2 15 grams. So we cross multiply. If we cross multiply, we have 2.0 into W1 minus 15 is equal to W1. We cross multiply. This will multiply this. Nothing is here. But let's see it as 1. Anything multiplied by 1 will be that thing. Are you following? So now let's open the bracket. So we have 2W1 minus 30 this times this will give you 2W1 or W1 to whatever. Okay, that's the law of multiplication for you. So this times this will give us 30 is equal to W1 minus 10. So let's collect like terms. If we bring this one to this side, it becomes minus. Okay, so we have 2W1 minus W1 is equal to, if this one comes to the other side, it becomes positive. So we have plus 30 minus 10. Is that okay? So 2W1 minus W1, just assume there's 1. In fact, that is actually 1W1. Okay, so 2W1 minus 1W1 will give us 1W1 is equal to what? This times this will give us what? 20. Okay, this is 1, so it's usually 1 times W1 is still W1. So we have 20 grams. So W1, like I said before, W1 is representing the weight in air. So we have found the weight in air to be what? 20 grams. Okay, I hope you enjoyed today's class. I'm still Bukola Joseph. Thank you for your time. Bye.